Hello and welcome once again to Mathspirational and my third video on solving trig equations. In this video we're going to be looking at trig equations that have been transformed parallel to the x-axis. So for example I'm starting with sine of x plus 2. So that's taking y equals sine of x and then translating it 2 to the left. There are various ways of doing this. You can go through, solve for x plus 2. Find all the secondary solutions for x plus 2, but to do that you're going to have to sketch the graph of x plus 2, and that's relatively straightforward actually, but later on we're going to be looking at trig graphs that have had at least 2 transformations done to them. So for example I've got tan of 2x minus 30, so it's been both stretched and translated parallel to the x-axis, and they could, if you really wanted to, throw some translations in parallel to the y-axis. So, I don't particularly fancy having to go through and sketch transform trig functions. I can do it if I have to. If I don't have to, I'm going to avoid it. And I'm going to avoid it by using a method called substitution. So the first thing I'm going to do for this first trig equation, our sine of x plus 2 equals 0.87, is I'm going to say let u equal x plus 2. So I get sine of u equals 0.87. Well, that's much easier to solve. However, if I'm going to replace u in my equation, I'm also going to have to replace it with my domain. So I know u is x plus 2. So for my domain then, I'm simply going to add 2 to the limits of my domain. So minus pi plus 2 and pi plus 2. So that's roughly minus 1.14 up to 5.14, thereabouts. Okay, so principal solutions. U is going to be the inverse sine of 0.87. So U is going to be 1.0552. Secondary solutions. I need my trig graph. So, between minus pi and pi, minus pi over 2, pi over 2, and pi, sine x looks like that. But I don't want that. I want it between minus pi plus 2 and pi plus 2. So that's going to take me a little bit beyond 3 pi over 2. And I need to get rid of a bit of that. Okay, so what 0.87 y x, bring it across, principal solution there, 1.0552 radians. So my secondary solution is going to be there at pi minus 1.0552 radians, which is 2.086 radians. So that's what u is. That's not what x is. If u is x plus 2, then x is going to be u minus 2. So x must be 1.0552, take away 2, so minus 0.9448 radians, and 2.086 radians, so 0.086 radians. An important last step, because it's actually solving the equation. Shockingly often, students forget to do that in the exam. They'll go through, they'll work out u, they'll forget to work out x. Now, like I said, you don't have to do this by substitution. You can go through and work out the values of x plus 2. However, the risk there is that people find their principal solution of x plus 2. We then go through, work out the value of x, and then use that value to work out the secondary solutions, which will then be wrong. Okay, you've got to work out your principal and secondary solutions of your transformed graph, and then from those work out the solutions for x. You'll notice that sine x between minus pi and pi, we'd expect to get two solutions, and for sine of x plus 2 between minus pi and pi, we also get two solutions. So, moving on to our second equation, cos of 2x is minus 0.42 between 0 and 2 pi. Now, for this graph, you'll notice we've been stretched by a scale factor of a half parallel to the x-axis. So that means that between 0 and 2 pi, rather than having one period, we're going to have two periods. Since for cos x between 0 and 2 pi, we normally expect two solutions. For cos of 2x, we're going to expect four solutions. So, just like before, we are going to do this by substitution. So I'm going to say, let u equal 2x. So cosine of u is going to be minus 0.42. My new domain for u, well, u is 2x. When x is 0, u is going to be 0. When x is 2 pi, u is going to be 4 pi. Okay. So, my principal solution then, well, u is going to be the inverse cosine of minus 0.42. So, my principal solution is going to be 1.813 radians. So now, secondary solution. So I need to sketch my graph. So I need graph of cos x between 0 and 4 pi. So pi, 2 pi, 3 pi, 4 pi, half pi, 3/4 pi. Okay, so I'm going to be coming down and up and down and up, minus 0.42. So just as we said, we're going to expect four solutions. We're going to have our principal solution at 1.813 radians. We're going to have our secondary solution at 2 pi minus 1.813. So that means my first secondary solution is going to be 4.470. My third secondary solution is going to be 1.813 plus 2 pi, which gives me 8.096. And my third secondary solution is going to be 4.470 plus 2 pi, which gives me 10.75. All of which you'll notice lie between 0 and 4 pi. Well, if u was 2x, then x is going to be u over 2. So my solutions then simply can be half my values of u. So that gives me 0.9066 radians, 2.235 radians, 4.048 radians, and 5.377 radians. Okay. So, now we've looked at two equations where we've had a translation and a stretch. Let's see about combining those into a trig function that's been both stretched and translated. So we've got tangent of 2x minus 30 equals minus 0.42. And I'm going to solve it in exactly the same way as I solved the others. I'm going to say let u equal 2x minus 30. So I've got tangent of u equals minus 1.42. My domain for u is going to be 0. Well, 2 times 0 is 0. Take away 30 minus 30 degrees, negative 30 degrees. And 360 times by 2 is going to be 720. Take away 30 is going to be 690 degrees. Okay, so that gives me my principal solution for u is going to be the inverse tangent of 1.42. So then u is going to, my principal solution is going to be minus 54.84. Oh, you'll notice that that's outside of my domain. So my first solution is actually not going to be my principal solution. For my first solution, I'm going to need my first secondary solution. So first things first, let's start drawing. Let's sketch us a graph of tan x between minus 30 and 690. Right, so 90, 180, 270, 360, 720. $360 minus 90, so that's going to get minus 30 there. So my graph is going to look something like I don't need to go away at 720, I just need to go up to 690. Okay, minus 1.42, it's going to be down here somewhere, which means this needs to be a little bit higher. So 1, 2, 3, and 4 solutions. Which again is what we'd expect. We'd expect 2 solutions for tan x between 0 and 360. So if I've got 2x, I'd expect to get 4 solutions. So principal solution is that. That's no good to me. So my first secondary solution is going to be that my principal solution plus 180 degrees, which gives me 125.15 degrees. I then add 180 to that. So 305.15 degrees, add 180 degrees to that, and I get 485.15 degrees, add 180 to that, 665.15 degrees. So that's u. Now, if u equals 2x minus 30, then x is going to be u plus 30 divided by 2. Now, if I was in an exam and I had 4 or more solutions for u to convert into x, I'd be tempted to use the list function on my calculator, because all I'll have to do is type in my values of u, type in the equation, and it'll convert them for me. So that's what I actually did. That gives me x equals, well, we're going to ignore my principal solution, not interested in that because it's outside of our domain. So my first secondary solution, once I convert it into x, is going to be 77.58 degrees. 167.58 degrees, 257.58 degrees, and 347.58 degrees, which is just below 360. So we have it, all four solutions. And that, ladies and gentlemen, is how we go about solving transformed trig equations. Now, in the course of Core 3 and Core 4 for AT Mathematics, you're going to solve a lot of these. In Core 3, you might be solving them explicitly, they might just be given to you. But in addition to that, they will crop up in some of the calculus questions, and they will crop up towards the end of some of the trig identity questions. So it's something which you need to go away and practice so that you can't make mistakes. Again, the real trick to doing this well is sketching those trig graphs. If you sketch them correctly, you will not miss out any solutions. And as before, you need to work out all of your solutions to u, and only then go through and find out your solutions for x or theta or whatever that you're using for your variable. Okay, in my next video, as I've said before, I'll be going on and having a quick look at trig equations that have been transformed in both the x and y directions, and from there we're going to be looking at trig equations that you get at the we're going to be looking at trig equations for which we have to apply trig identities to make them solvable. Okay, thank you very much for listening. If you liked it, if it helped, please like and subscribe.